In today's video, we're going to build a hybrid power amplifier. This is a 20 watt per channel stereo amplifier that uses two vacuum tubes in the preamp stage, which also operate as your headphone amplifier, and a solid state output to drive speakers to 20 watts. I received the package from IC Station. Actually, it has a bunch of stuff in it, a bunch of kits that we're going to build. And the first one I found to be the most interesting one, so that's the one I'm going to build first. As you can see, this one has some vacuum tubes in it. This is an amplifier kit. I think this is probably going to be quite a popular one because in addition to it being a headphone amplifier, well, this one's a hybrid amplifier. This one will actually produce, I think it's 20 watts per channel. It uses ICs as the outputs. Here's the little tubes here. These are, I think these are little triodes, if I'm not mistaken. They are 6J1, but that's the Chinese numbering system, so don't look up an American 6J1 tube because it's not the same. Let's open up our package of parts. Now, I've built a kit from this particular company before, and it was very high quality. The other little preamp that I built was from the same company. It's very, very high quality. I think it's a very good little kit. Comes with good quality capacitors in here, right? Nikon caps in here. Very good quality kit, very inexpensive. In fact, the power transformer that I had to buy, look at here some of our audio capacitors on this thing. Yeah, it's going to have blue lights below the tubes, but you know, I mean, look at these little caps here, right? These are what brand are these ones here? Purple ones. These are Elnas, but they're the audio grade. Right, these are their audio grade, audiophile grade caps. As I say, the last one I built was really good quality, and I'm expecting that this one here is going to be very good as well. It comes with instructions, which a lot of kits do not. Now, unfortunately, the instructions are totally written in Chinese, so you're going to have to translate. If you really need to understand what this says, you're going to have to translate. But we can get the gist of it because it tells us what our values are here, right? It tells us that, if we look at this, okay, it tells us here that it's using LM1875Ts, that's the output ICs. And here's the specifications here, 14 hertz to 100 kilohertz. Okay, our total harmonic distortion is 0.04%. We have music power, it looks like 20 watts per channel. That's probably peak. I haven't translated this. It'll run into a 4 or 8 ohm load. It's got headphone output. 105 dB, I believe, is the signal to noise ratio. And the tubes says it can use a 6AK5, 5654, 6AU6. I guess those are the equivalent tubes that you could use on this thing. But anyway, it's not going to be hard to figure out what values of parts that we use on this. And it comes with a nice color picture, a full schematic. These are pentode tubes, looks like. Yep, they're pentode tubes. I thought they were little triodes, but they're not, because I can look at the schematic here. And basically, if we look down, let's study the schematic before we actually even get into building this. And I'm just going to move all these parts out of the way here so that they don't, hope I don't lose any. We'll just move them back on the bench. I have cleaned up the bench a bit from the other stuff, and I'm going to keep it this way until I finish this project. But let's just take a look at the schematic of this unit. So, looking at the schematic, it's powered with AC transformer, and it uses a split 18 plus our 18 volts with a center tap. So a total 36 volts with respect to ground. So I went out and I bought myself a nice beefy transformer here. Okay, 18 and 18, 4 amps. This costs more than the kit. The kit's about, I think, 12 or 13 bucks for the kit. This transformer was about $30, but this is one that I'm going to be using because it'll power some speakers. So I'm going to actually be using this little amplifier. So I want to make sure that it's going to be good. And even though in this particular instance, I probably won't be mounting this in a case in this video, this is one that I probably will mount onto something, either a block of wood or something. I want to show it off though, so I don't want to enclose it, but I'll probably mount this onto a block of wood. If I can find a little piece, I might even do it in the video. Mount the transformer and everything down onto a little piece of wood because I want to keep the tubes open so you can see them, right? So here we have a bridge rectifier. You create a positive and a negative voltage off of here. And although it doesn't seem like a lot, these tubes don't require a large B plus voltage for these ones here. They work off of, I think we're going to have about 36 volts between the two. Let me just get my magnifiers on here so I can see the schematic a little bit better. So it looks like we're going to have a plus 25, or they say the 25 volt capacitors. Then we're going to probably have about a plus 20 and a minus 20 supplier, so somewhere in there when you rectify. Our positive and negative supply is going to feed our op amps down here, and these will feed the speakers. Here's our speakers, and it's not a bridged tied load. You see here, our speakers are grounded, so we can actually use these on a common speaker. Right? These are not a BTL type of bridge tied load output. Here's our input here. Input is over here. It's going through the two vacuum tubes, and the vacuum tubes themselves will drive the headphone output. So the headphones are driven directly from the tubes. Looks like. Here we go. Yep, right off of the plate of the tubes here to the outputs, and the plate of this tube here goes through to the outputs. So that's the headphone amplifier on this, is directly driven from the tube. When the headphones are unplugged, the signal then from the headphone output goes down into the IC power amplifier for the speakers. So in this sense, it's using a couple of pentodes that will drive your headphones directly, or you can use it with speakers, which is what I found was quite unique on this particular unit, and I'm excited to build it. So enough from me talking about the schematic, and let's go building. Now I'm just looking at this thing again. There's a couple of transistors in here. What exactly are these doing here? We've got a couple of transistors in this circuit here. These ones are probably in the regulation for the tubes, I'm thinking. The caps are 36 volt caps. And one's tied down to one supply. And the other one is tied, yeah, so these are in the tube power supply. I'm just looking to see if this is the doubler in here. I see a couple of transistors, so they must be regulated of some type. This is a regulation circuit. I was expecting this to have a voltage doubler in it, but I don't see a doubler. I see basically two 470 microfarad caps, 36 volts rated here on the output. But this isolates. This is a regulator circuit. Our unregulated B plus coming in from the VCC and the VEE lines here go into the Q1. Q1 is biased on through this resistor divider network here, which also then biases on Q4. And this gives us this is our regulator. This is to remove ripple, I think. Yeah, this is to remove your ripple. This is a basic regulator circuit to remove ripple that might sneak through from the rectifier and create noise and hum and stuff in the tubes. So this is isolating the power supplies for the tubes from the power supply that drives the IC. Because if you notice here, the direct B plus and B minus goes directly into your PID, I think it's PID 5 of the ICs, and the B minus goes into PID 3 of the ICs, but it's unregulated. So this is just a regulation circuit to isolate the tube, which is the preamp, from any ripple. Now these being small signal tubes, they don't require the hundreds of volts that conventional tube circuit would. So let's get building. So the first components I'm going to mount are the 4.7K resistors, are 1, 3, 10, 13, 17, 18, 20, and 21. We have 8 of them here, 4.7K. So that's yellow, violet, black, I think it's brown, and brown. 470, and then 1 extra 0. These are all precision resistors. So let's find, and they're also marked on the board here, you see, which is nice. That's what's nice about, excuse me, that's what's nice about this kit, is that the board is really well made and everything's labeled. Right, everything's labeled here, and it even tells you what your voltages will be, like plus 22 volts, minus 22 volts, plus and minus 22, 12.6 volts across these points here. Your power transformer goes here, plus or 18 and 18 with respect to ground, and you have to use an 18 volt transformer too. You don't want to, you can't do it on a 12 volt dual like the other little tube amp, the little tube preamp I built. I used AC 12 volt. It was just a single supply AC 12 volts, and it used a voltage doubler to generate the higher voltage for the tube. This one here requires a split supply. So the first two 4.7K resistors go here, R3 and R1. Mount them down. And then we have R10 and R13. R10's here and R13 is going to be over here. Again, they're marked. So we get our next two 4.7K resistors. I've got the heat on out here because it cooled down last night. I actually had a little problem with my car this morning, which I probably won't bother to show you the video on it, but there's a nasty feature on, and I don't think it's just the Volt, I think it's probably all the GM cars, but there's a nasty feature that is, somebody thought this was a good idea, and maybe if you live in the desert, it is. But they have the ability that you can press and hold the unlock button on your fob, and it will not only unlock your cars, but it will also roll down all of your windows. And maybe if you live in the desert and you're coming out to your car and it's been sitting in the heat all day, you might want to be able to roll down your windows to let the heat out before you get to the car. I'm sure that that was the well-intended idea of it. The problem is, you can't turn it off yourself. It can only be turned off by the dealer, as they have to use a scan tool to do it. And they need to know the code to do it. And well, I bumped my keys last night in my the key fob got squeezed between a couple coins, and it rolled down my windows before I went to bed. And the problem was it rained all night and my car got full of water. So my upholstery is all soaked, my carpets are all soaked, and I'm not very happy. So I kind of took a video of the damage, but I'm probably not going to show you guys it unless I don't get satisfaction when I go in to have them deprogram that. When I bought the car, it was deprogrammed by the selling dealer, but last year when my car went in for an update to the software, they reprogrammed everything and forgot to set it back so that the windows don't roll down when you press the button. And I found out last night, actually I found out this morning, that my car was flooded, so I'm not too happy about that. Okay, next is R17 and R18. Again, we're looking for the 4.7Ks. It's a 47, 47, where's my 4.7s? There we go. 4.7, marked as 4K7. Will be these two down here. So there's 2 more of them right in the middle of the board here. There's a total of 4 more total. There's actually all 4 of them go right here. 2 there and 2 there. So let's mount all 4 of those, and that will get all the 4.7K resistors out of the way. So we'll just mount all those ones. Oh, I can just hear it from someone right now. I mounted one of these resistors the opposite direction. I can just see it right now. Someone's going to be mad about that, you know, because the electrons are going to go the wrong way through the resistor. And I'm serious though, because some people actually will believe that. If you've seen the snake oil that they sell people in hi-fi stores, cables, and there are different qualities of cable for sure. No argument there. Some cables are better quality than others. But it's not what you would think. I was at a customer's place just yesterday upgrading their 1080 set-top box for a 4K set-top box, and I had no video. We were trying to figure out why is there no video, and what the problem was it was their HDMI cable was not compatible. Now I can just hear you guys right now. Well, yeah, that's because you have to use a high quality HDMI cable. You're right, you do. The cable that they had was one of these expensive boutique, over $100 cable, a monster cable, and it didn't work. And I went and got a very basic, like $5 HDMI cable, real thin one, plugged it in, and it worked fine. The other cable worked fine on their regular HD set, but on the 4K set-top box, it gave no video whatsoever. So cables do make a difference in some cases, but it's not always the ones that you pay a lot of money for. The one that I took out was one that it had directional cabling on it. I can see if it makes a difference. But some of these slick salesmen will convince you that you have to have directional free wire that's, you know, or oxygen free wire, and it's going to make all the difference in the world. And I think the only people that will hear the difference is the people that spent the money to buy it. But okay, that's the 4.7Ks. Let's go to the 1K resistors now. There's 4 of them. 4 1K resistors, so let's find the 1K resistors here. So the 1K resistors will be brown, black, black, brown, brown. There's 4 of them. And these go in R2, R4, R30, and R31. So let's find those locations. There's R2 and R4 right here. And the other ones are probably going to be over on this side. Maybe not. There's 2 of them there. And the other ones are 30 and are 31. So 1 there, and 2 of them right here. I can say this is a really high quality plated through board. I'm really impressed with the quality of the board this one has. Likewise, the other one also had a really good quality board. It sure makes building a kit a piece of cake when you're dealing with circuit boards that are of good quality compared to ones that are of, you know, mediocre quality. Best practice for kit building, of course, is to mount all the smallest parts first and work your way up from there, which is generally the way that I will do it. The exception being is when I've built a couple of the clocks. The Nixie tube clock, for example. Vacuum fluorescent clock. I tend to follow the instructions on those ones because there are typically tests that they have you do mid-build to verify that everything's working. So they have you build a small portion of the circuit, like for testing the boost converter, for example. You'll build the boost converter circuit first, and then you'll go and add the next stage. So in those cases, you have to put the parts in order to be able to test it. But in this case, there's no instructions with this. They just give you the layout, and they give you a bag of parts, and they give you some Chinese instructions, which are relatively easy to figure out what you're doing, even if you don't read Chinese. Next is 47 ohm resistors, R5, 6, and 7, and 8. There's 4 of them as well, and all 4 of them go down here. R5, 6, 7, and 8. This one's yellow, violet, black, gold, brown. 47 ohms. Next is a 56K resistor. This would be green, blue, black, red. Green, blue, black, red, brown. It's R22 and R23. Next, the 200 ohm, which is R12 and 15. R12 and R15. Next I have R16 and R19. These are 100K. Brown, black, black, orange. So R16 and R19. They go down here, I believe. 100K, yes. So next we have the 22K, R24, 26, 27, and 32. 24 is down here. $32 is up here. I believe there's one more resistor pack here to go in. Two more quarter watt and a 2 watt resistor. The last one here is going to be a 10 ohm. Brown, black, black, gold. R25 and R28, and that'll round up the quarter watt resistors. One goes there, the other one goes over here. Now I'm going to keep this one for later, just because this resistor is going to be mounted up off of the board. It's going to be left up a good 1/4 inch from the board, because this one is going to get warm. So we want it to be able to dissipate heat. But this one here goes right here on the board. But I'm not going to mount it flush with the board. I'm going to leave this one standing up, beside the capacitor, so that the heat will radiate. So that'll be mounted later. Let's move on to the small capacitors now. So C13 to 14 or 47 microfarad at 10 volt. Here's these ones here. These are little purple ones. That is C13 and C14. These are polarized. The shaded side is negative. Just looking at the drawings here. And the shaded side of the board is the negatives. Okay. So the long lead is positive, so they're going to go in like this, negative to the shaded side of the board. Okay, the 0.1 caps are next. These are not polarized, so let's drop them in. Marked 104 on the board, 0.1 on the cap itself. C15 and C16. They go down here. Next to the blue 1 microfarad capacitor, C9, 10, 11, and 12. There's 2 of them there. There's 11 and 12, and 9 and 10 are here. So these 4 go in next. These are not polarity sensitive. Now we'll mount the electrolytic caps. We've got 2200 at 25 and 470 at 35. So we get the 470 at 35s. Actually, no, I'll mount the transistors first because they're a little bit smaller. So I got Q1, Q4, Q2, and Q3. We're going to look up what values these things are. Okay, Q1 and Q4 is the 2SD667. So here's Q1 and Q4. We'll put those two down here. Note the polarity that they go in. And of course the other ones are 2SB647, and that's Q2 and Q3. Again, note the orientation. Okay, transistors are mounted. Now we can go ahead and mount the capacitors. So the 470 at 35 volt go in to these outside here. The ones on the outside edge. Again, polarity. Be aware of your polarity. The shaded side is the negative. So here's the 435 volt 470 microfarad that go in here. And there's 2200 microfarad 25 volt that go into these other spaces here. The caps go in just like that. Put the big resistor in now. And this has now completed the majority of the parts. I still have the output ICs and the heatsink to mount, and the main rectifier, and of course the tube sockets, along with the blue LEDs. Why they chose blue, I have no idea, but they all seem to use blue ones, and I don't have any other colors. Or do I? I'm pretty sure I don't. So I'll just put these in. What the heck? I know blue looks stupid, but they all seem to use blue for some reason. They seem to think we like blue. They should put orange, if you ask me. If you want to enhance the tube color, at least make them light up the same color as the filaments in the tube, right? And I do have a little amp that I built last year that does use orange LEDs. And they look pretty good. That was the first kit that I built, the little 2 watt per channel Class A ELE kit. Okay, Okay, tube sockets. Before Mr. Troll can say anything, yes, they are ceramic, not plastic. Because I know Mr. Troll out there said that the last one that I built were plastic and made a comment that they should have used ceramic, and they actually were ceramic. And I'm just showing you guys that these ones here are also ceramic tube sockets. So tube sockets go in. I don't have a lot of clearance here beside this capacitor. I may have to rework this little blue cap. This is a lot bigger than what I expected it would be, and there's not a lot of room in here to mount this tube socket, so I'm going to have to kind of move this out of the way a bit if I can. Lift it up a little bit. But it will fit. Bit of coaxing there. That socket went in no problem. Same with this other one. It'll fit in there no problem as well. So we'll just bend over a couple of the tabs here just to hold the socket in place while I solder it in. Gonna bend over a tab on one that's actually connected to something. Okay. Now we'll solder in the tube sockets. Okay, tube sockets are mounted. Let's get the ICs and rectifier mounted next. That's about all that remains, plus the controls, and then we'll be able to test this thing. Cool, mount the big rectifier down here now. The rectifier has a positive and negative side. There's the AC input here. The side's marked with a plus, the side with a minus. So it's just going to sit down here on the board like this, and there's no, it's not mounted to the heatsink. There's no hole to mount this. The only things that are mounted to the heatsink are the actual ICs themselves. So this can just be mounted flush because this unit's not going to draw that much current, not compared to how big this rectifier is. So we'll just tack this down. My little bag of mounting hardware for the, I think this is for the transistors, or the ICs. Should be some screws in here as well. Now remember, we have to insulate these ICs from the heatsink with the heatsink insulators that are going to go on like that. The ICs are going to be mounted like this with these plastic inserts. So now the heatsink is mounted. We can then go and put the put some thermal grease on the heatsink here as well. So we'll put some thermal grease down here on the heatsink. And on this side as well. And we can put our insulators in here, our 2 insulators, lining up the holes. Get some grease onto the front of the insulator as well. They don't give you much thermal grease in this package, that's for sure. I got lots, so I mean that's not a big deal, but I got a whole big jar of it, but might as well use the stuff that they gave me. And then we want to get the ICs in place. Now you gotta be careful with these pins that you don't bend them too much, because they will break easily if you do overbend them. Just gonna drop the ICs in to their preformed holes. There we go. I think we're okay. I think we're okay there. I can get this IC in place, get the heat sink, get the insulator in place here. Just like that. Get the insulator on there and drop the screw through. I think that one will be okay, and the other one's fine. It was just this one that I was a bit concerned about, because one of the legs was really quite flimsy coming out of the IC, but now that it's mounted, it should be okay. This other one here, I didn't have the same concern over, but one of them, the leads was, see, they got kind of a bit crunched in the package here. They're preformed leads, but one of them got a bit deformed. So hopefully this one won't be the same, won't have the same issues. I'll be able to drop this one in here and then solder them in once they're in place, once I've got them secured. Okay, that one's in place. And the second insulator goes in there like that. That's to isolate the screw from the actual heat sink, or from the tab, I should say. Okay, that one's in place. That one's in place. And now we can solder the wires through. That one's through. All the pins on that one are through. This one here, these pins are going to be lowered down a bit. There we go. Okay, there's the unit, pretty much completed. We just have to mount the volume control now in the middle here, and the headphone jack and the input jack, and then of course the speaker jacks. So here's the volume control going in the middle, like that. We've got the input and output jacks here. Now I think the two of them are different. Where are they? Are they the same or are they different? No, they look like they're the same jack. Okay, so they've got switches internal on them, but they're the same. They're the same jack. But one's a headphone jack and the other one is the input. And I do believe they're the same. Yeah, they're exactly the same. Now all that remains is the two speaker jacks and the power jack. So here's the two speaker jacks. Be sure you get these mounted the right way so that the speakers can actually be connected. If you hook them up the wrong way, you'll never get the wires in them. And finally, the power jack, same thing. Make sure you mount it the right way. Otherwise, you'll create headaches for yourself. We have some standoff to mount onto the board here. Volume control, if you were to mount it into a cabinet. It's got a nut and a washer and another nut. This is for chassis mounting at a cabinet, which I will probably do at some future date. Even has a nice little knob for the, oh, there's the other nut I was missing. It was stuck inside the knob. So there's the volume knob there. And the last standoff. Of course, we've got these standoffs for one reason, because this unit here operates at, not a high voltage, but it's, plus and minus about, 48 volts or so. I guess is the potential between the two of them. What are we running at here? What's it say on the schematic? Let's look that up. But vacuum tubes require a higher voltage than the solid state products. I think it's plus and minus. Well, it's plus and minus 18, but I think by the time it gets rectified and everything, it's going to be like 24 or so volts per leg, and so that'll give you 48 volts difference. So 48 volts, you want to keep the unit off something, you don't want to put this on a metal bench or anything. It's going to short out. So it comes with little standoffs just to hold the connections off of the surface that you're working with. I think I've got everything complete here. Looks pretty complete to me. Just got to mount the vacuum tubes and, of course, set up the power supply. So there's the two tubes mounted. Now I just got to get the power supply wired. So this has got two primaries on it. We'll put them both in parallel, 0 and 0 and 120 and 120. Of course, the reason they do this is for 240 volts, you'd put a jumper between these two, and then your input would be here. You see, then this could be a 240. But we're only on a 120, so we're going to just jumper these two together and jumper those two together and run our line cord to it. Okay, I'm getting my jumpers prepped to connect the transformer up to power. So what I'm going to do here is I'm going to attach these wires that I've already tacked on. I'm going to attach them to the main cord and then pull some heat shrink tubing over it, and then attach the end of these to the other side of the transformer. So we'll solder these on here. Shrink this piece down. Tie this one down to the other 120 volt tab. Solder it on. Something like that. Bring the heat shrink tubing down, cover it, heat it up, and the second 0 volt or neutral side. Not that it matters because it's a transformer, right? So as long as we have it in phase, we'll have an output. If we have it out of phase, we'll have nothing. So that one's connected. Let it cool a bit. Push our heat shrink tubing over here. shrink it down. That'll prevent accidentally touching this thing and getting a shock. We can plug it in now and we'll see our voltage on the output with AC volts. And we should have 18 volts. 39 volts, okay. 19 volts, 19 volts. So there we are. There's our center tap, 19, 19, 39 between the two. Good enough. Okay, let's hook it up and see whether this thing works. Probably going to hear it from everybody for doing this, but I'm just going to use some Cat 6 wire, 3 pairs of it for my secondary side. I'll use the green for the neutral and the orange and blue pairs for the power sides. Because this should have more than enough current carrying ability for what I'm going to use this thing for. So we'll just solder this down here. Okay, the other end of the wire, we'll strip it as well the same way. Okay, our green wire is the center. Whoops. Okay, I've now connected it to my speakers. We just have to find an audio source to plug into it. Okay, I've got my trusty MP3 player here. We'll just plug it in. And I haven't applied power to this yet, otherwise these things would be lighting up blue. Get a better shot of this thing so you guys can see it a little better. And I'll put the power on here now and we'll see whether this thing does anything. Of course, there'll be a delay when I power it up because, of course, the vacuum tubes have to heat up. So there we have power. Make sure it's got some volume. As the tubes heat up, we have sound. It actually sounds very good. Wow. I don't know why they put blue LEDs in the bottom. Part of the, and I'm going to kill some lights in here so you guys can see this thing glowing. So let's just start turning out some bulbs around here. kill the main lights. So I don't know what it is about blue LEDs. I think I'll disconnect them because something about vacuum tubes, you want to see the glow. I mean, you can see the glow here. I know you can see them there, right? You can see the filaments glowing on the tubes there. But my other amp that I built that has the orange LEDs looks superior. But I still prefer a tube amp that has no external lights. Although you don't have to put the LEDs on, you can leave them disconnected. It's easy enough to disconnect them. Maybe I'll disconnect them and show you guys what it looks like without them. But this has got fantastic sound. So what they've done here, this is what's called a hybrid amp. Just gonna turn some lights back on. This is what's referred to as a hybrid amp. All the hybrid amps work like this. Luxman did it with their LV103 and LV105 series. They had two, in the case of the Luxman, they were dual triodes, I believe. And how they were configured was they were configured as a preamp, and I believe it was the phase splitter because it was a class AB, or they were configured as just two stages of preamplification. I forget. I'd have to look at the schematic for it. May have been two stages of preamplification, and then it went into the standard MOSFET-driven 60 watt per channel amplifier. One of the best sounding amplifiers that I own is that Luxman LV103. I use it in my studio. I've built two Class A amplifiers, both from ELE kit, and they are single-ended output, so they are relatively low power. One of them is 2 watts per channel. Fantastic sound, but only good for low volume. The other one can be configured in triode or pentode mode, or ultralinear. And I normally run it in ultralinear mode. It gives me about 8, I think it's 8.3 or 8.4 watts per channel in ultralinear. Again, it's single-ended, so one tube does the entire waveform. This is a hybrid amplifier. So if we look at the schematic, we'll see the signal path. Let's look at the schematic. If we look at the schematic, we'll see that the signal path comes in here, goes through the volume control, goes through a balancing network here to drive the grid, the control grid of a single pentode. One for the left channel, one for the right channel. The plate from the pentode goes through C9 and C10. These are to isolate the relatively high voltage, which is going to be about 36 volts, I guess, with respect to the negative. So the negative supply feeds through a 200 ohm resistor to pin 7, the cathode, and to pin 2, the suppressor grid. And the positive supply is going to feed the plate and the screen on pin 6. And your audio signal obviously going into pin number 1, which is your control grid. So this is your high voltage potential difference between the cathode and the anode. You've got a plus 26 and a minus 26, so you get about 52 volts, I guess, difference, which is not high for a vacuum tube, but these ones are not high voltage tubes. They work fine. Anyway, your plate, your signal comes out the plate and is blocked by C10 and C9. That removes the DC component where it goes to the headphone jacks here. Right, here's one path to the headphone jack, and here's the other path to the headphone jack. If you plug in the headphones, of course, it disconnects pin 2 and 3, which is the pass-through, and then your sound from the vacuum tubes drives your headphones directly. So it's a full vacuum tube headphone amplifier, and if you unplug the headphones, then the tube buffered signal then passes through to the LM1875, which will deliver about 20 watts, I guess, to the speakers. This thing sounds fantastic. I think you guys are going to like building this one. It doesn't take that long to build. It took me a couple of hours to put this thing together. And as I said, the board is very straightforward, very easy. You don't have to read Chinese to put it together. I certainly didn't read Chinese. Well, here's a good acoustic one. These little ICs produce a fair bit of heat. That's why the big heat sink. Final one with some vocals so you guys can hear how that sounds. Okay, here's a royalty free with some vocals. Well, I can say after hearing that, the vocals are really clear. I mean, these are not real high-end speakers. These are just some Polk audio bookshelf speakers. But this is as good as I've heard these speakers sound. I mean, this is really, I'm really impressed with this thing, especially for what this kit cost. As I say, the kit itself is insignificant. You're paying nothing for the kit. And you're building it yourself, so it's not made in China. It's made in whatever country that you are in. The most expensive part of this is going to be the transformer. If you don't have an 18 plus 18 volt transformer, you're going to have to buy one, which I did. But that's a small investment. I think I paid about $30 for the transformer. That's the most expensive part on this kit. I would recommend this. This is fantastic. I'm going to make one small modification to it. I'm going to disconnect those ugly blue lights. These are the two resistors here to drop the current down for the LED. So if we disconnect these two, we'll have no blue LEDs. Okay, there's the unit without the LEDs connected. Now you just get the glow of the tubes themselves, which there's not much glow on these ones. You know, I don't know if I like the lights are better on or off. Let's see. There's one on and one off. Turn on the lights and see how they look. Anyway, you can decide which way you like it, eh? Definitely looks better without the lights. You see the cathode heated up inside that entire tube. Looks very cool. Yeah, definitely looks better without the blue bed. So if you're putting one of these together, don't hook up those two resistors and you don't have to, or you can just leave the LEDs out. They're not needed. Okay, that's it. I hope you enjoyed this video. Great little unit. The link to where I got this from came from IC Station. Get a lot of products from them, and this is another great one. If you like what you see on this channel, please consider supporting my channel either through PayPal or through Patreon. It's through your contributions that I can build projects like this. All the money that comes in through either PayPal or Patreon subscribers will go to future projects like this, because again, I do have to buy hardware like transformers and so forth to build these projects. So everything gets rolled back into the channel. And for Patreon members, you guys can ask me all kinds of questions and I'll do my best to answer them. But I'm starting to cut back on my support to non-members just because it takes up so much of my time researching all these questions when people ask me specific questions for to answer their technical problems. So I'm giving priority to those people that are supporting me either through Patreon or PayPal. People asking questions that way will get the support a little quicker than if you just ask the questions in the channel, because I get overwhelmed with so many questions about specific things that I just don't have time to sit down and answer every single question for every person out there on the internet, but I will certainly do my best for those that are supporting my channel. Thanks for watching, and we'll catch you again real soon.